thanks all for for inviting me. So, am I audible to you all?
Yes, sir, you are.
Okay. Thanks a lot. And it's been an honor for me to be here. I've been invited. And first of all, I address to all of you assalamu alaikum, good morning, good evening, whatever the zone you are in from. So please accept my warm greetings. And as I said, it's my honor for me, to be given chance to talk in this international conference of the computational intelligence. So I was looking for it, and when my very dear friend Asif Rashad Khan talked about this, I was just I was just thinking that it's going to be great. It's a great initiative by the department, and uh, it's going to give the uh, new level of thinking and a new era what we are going through. Uh, so it's going to give the great chance to all of the students, all the industries are going through these days. So, I have a couple of PowerPoints slide deck which I want to share. And since the time is very less, I won't go very thorough, but still I will give you the glimpse of what all the industry's standards are there. So we will go through from there. And while I'm presenting, I will just turn off my camera so that the streaming can go flawless. Is that okay with you all?
I just want to mention that we will have the talks and we'll invite you for the talk in a while, so we can consider your insightful talk after that. Is that fine with you?
Say again.
We will invite the sessions in a while. Once I invite all the is that fine?
Yeah. Yep. You just
Thank
please tell me when to start. I'm fine with that.
It is all.
Yep.
Ladies and gentlemen, let us welcome him with a round of applause. May I now request Dr. Maria Lapina from North Caucasus University. She'll be joining us soon, so let's wait for her. And after that, next, it gives me immense pleasure to invite Dr. Shahid Tufail from Next NRG LLC, Miami Beach, Florida, USA, who is also a proud alumnus of Aligarh Muslim University and will be joining us virtually. Dr. Tufail, a very warm welcome to you. If you can hear us clearly, may we request you to acknowledge your presence with a brief break. Thank you, sir. We are grateful for your presence despite the distance, and we are delighted to have one of our own back with us today. Ladies and gentlemen, please put your hands together for Dr. Tufail. And we are also honored to have with us our esteemed speaker, Dr. Maria Lapina from North Caucasus Federal University, Russia, who will be joining us online. Dr. Maria, please acknowledge your presence with a brief wave. Can you hear us clearly?
Yes, I can hear you. Many thanks.
Thank you, ma'am. We're delighted to have you with us today. Let us welcome her with a round of applause. May I now request Dr. Faraz Masood, Assistant Professor in the Department of Computer Science, Aligarh Muslim University, to please welcome all. And finally, I invite Dr. Mohammad Nadeem, Assistant Professor in the Department of Computer Science, Aligarh Muslim University, to kindly join us on the stage. Please welcome us with a round of applause. Thank you to all the esteemed dignitaries for gracing the stage with your presence. We're truly honored to have all of you with us. Ladies and gentlemen, we shall now proceed with the bouquet presentation ceremony as a gesture of our respect and appreciation for our esteemed dignitaries and speakers. First, I respectfully invite Dr. Faraz Masood to kindly present a bouquet to our presiding chair, Dr. Parvez Mahmood Khan. Please put your hands together, sir. Next, I invite Dr. Mohammad Nadeem to kindly present a bouquet to our esteemed keynote speaker, Mr. Mehroz Ali Pasha. We would also like to extend our heartfelt appreciation to our distinguished speakers who have joined us virtually. Let us acknowledge their valuable contribution with a round of applause. We shall now proceed to the memento presentation ceremony as a token of our sincere appreciation for the guidance and contributions of our respected dignitaries and speakers. I respectfully invite Dr. Faraz Masood to kindly present a memento to our presiding chair, Dr. Parvez Mahmood Khan. Next, I invite Dr. Mohammad Nadeem to kindly present a memento to our esteemed keynote speaker, Mr. Mehroz Ali Pasha. We would also like to extend our sincere appreciation to our esteemed speakers who have joined us online. A virtual memento is being presented to each of you in recognition of your valuable time and insightful contributions. May I now request the organizing team to kindly present a memento to Dr. Maria Lapina. Thank you, ma'am. We are truly grateful for your participation. Next, we present the virtual memento to Dr. Shahid Hussain. Thank you, sir, for your valuable presence. Finally, we present the virtual memento to Mr. Mohammad Suhail. Thank you, sir. We sincerely appreciate your presence. To formally commence this session, I now request Dr. Mohammad Nadeem to kindly take the proceedings forward. I also want to make a note that I want to request all the speakers to please conclude the sessions within 15 minutes because we have multiple speakers and we have a time limitation. So thank you so much for your understanding. And with this, I hand over the stage to sir. Thank you.
Thank you, Anushka. I welcome all the experts from the industry who are present today, both offline and offline. Our presiding chair, Dr. Parvez Mahmood Khan, sir, our chairperson, sir, Professor Arman Rasool Faridi, sir, faculty members, delegates, alumni, and participants present both online and offline in this very special and important session. Today, three experts, Mr. Mohammad Suhail from NTI Mindtree USA, Dr. Shahid from Next NRG USA, and Mr. Maria from North Caucasus Federal University, Russia, have joined us online, and Mr. Mehroz from AHA Technocrats, Noida, is physically present with us today. I welcome you all once again. And a special welcome to Professor Asim, who has joined us as the IEEE observer on the second day of our international conference. Let me start by introducing our presidential chair, Dr. Parvez Mahmood Khan. He is a PMP and IBM certified senior IT professional and has relevant and in-depth experience of more than 28 years now. He has a proven track record of excellence in heading numerous large-scale programs and deliveries at a global scale, not only in India, but overseas as well. His experience is spread across global IT industry, technology management, professional consultancy services, research, innovation, and academics. He has designed and implemented advanced and specialized courses in cloud computing for MTech computer science and engineering students at various prestigious universities, and has also mentored faculty members for instruction delivery in cloud computing domain. He is currently handling the role of Director Computer Sector at Aligarh Muslim University. So thank you once again, sir, for joining us. Industry talks are very important because they join two different words, academia and industry. These talks enlighten the students how real-life industry works, how softwares are developed, and what kind of considerations make a product useful. Students get to know so much more that textbooks do not explain. Another benefit of such talks are that students learn the importance of soft skills like communication, presentation, etiquette, and corporate grooming. Conversing with successful people is the biggest motivation, and students gain in many ways. So I am sure this session will be very beneficial for all of us. Our first speaker for today's session is Mr. Mohammed Sohail. So let me take this opportunity to introduce him. Mr. Mohammed Sohail is a senior specialist data engineer at LTI Mindtree USA. He is a data architect and technology lead for over 20 years of experience in designing large-scale data platforms, real-time analytical systems as well. He is a proud alumnus of Aligarh Muslim University, in fact, Computer Science Department 2001 batch. He specializes in telemetry data streaming, distributed data architectures, high performance data engineering across both cloud and on-premise environments. At HP Enterprise, he played a key role in developing a high-velocity observable platforms for HPC interconnect and frontier supercomputer. He was instrumental in designing telemetry pipelines capable of processing millions of matrices per minute, leveraging advanced technologies such as Telegraph, Kafka, Victoria Matrix, Timescale DB, Open Telemetry, and Open Search to enable real-time monitoring and performance analysis at scale. Thank you, Mr. Sohail, for joining us today. Now, I would like to invite you to deliver your talk. Dr. Sohail, stage is yours.
Thank you. Thank you for honoring with the doctor. I'm not the doctor though. So, let me start with so first of all, I would like to, thanks to all of our distinguished guests and the respected faculty members. There are many faculty members out there before whom I got a lot of my education, and I stayed there. I studied there in the department for 6 years, and the department not only gave me the technical paradigm of thinking, but also it nurtured the characteristics and the attributes in me. I know the parting notes by Professor Asim Zafar Sahab, Professor Suhail Mustajab Sahab. Those are still ingrained in my mind, that what all they said. They have been delivering all those parting notes to every year students. But it really meant a lot. It shaped where we are right now. So I'm really grateful to all of you. And again, this is all for the students, all my uh, distinguished, speaker online, you know, all the students who are there, all the brilliant students. I would suggest you all to focus more on the character building, your attributes, your attitude, and all those, along with your along with your studies. I'm not saying that your programming language and your analytical skills are not going to matter. That all matters, but what all mostly matters is your characters, your attitude to learn high, attitude to learn more, and all. So with that, I would like to start my slide deck. I was working until last year. I was working for the Hewlett Packard Enterprise, which is the largest supercomputer manufacturer. That's the Frontier. So I was part of one of the Fabric Connect, uh, uh, Fabric Connect monitoring tool. So this is the one. Actually, I'm sharing my screen, and while I'm sharing my screen, I will turn off my videos so that the streaming goes seamless. Is it visible to all of you, or
Yes, Dr. Sohail, clearly visible.
okay? Let me make it as a presentation mode, so that it can be visible more. How about now? Is it okay?
Fine. Yeah, it's much better.
Yeah, okay. So at any point of time, especially for the students, who are there, who are attending this talk, at any point of time, if you want to reach out to me, I have shared my phone number and my email. You can write me the email, you can send me the phone, and then we can be in touch. But this is very rare kind of thing. I don't think so you would be able to get into these kind of things until you join to any of the industries. So this is regarding the infrastructure and the performance monitoring of the fabric interconnects in supercomputing. Fabric interconnects is basically the networking out there. you know uh, while I was there in university, Professor Asim Zafar was the one who were teaching us that networking. At that time we were thinking, oh, whether we would be able to get chance to work on this kind of work later, but this is where I am right now. So I worked on that supercomputer infrastructures monitoring and all. So what happens, like monitoring and the observability, these are the two terms which are widely being used in the industries. Especially when the AI came into the picture, mostly in the last 4 5 years. Observability came into the picture, and monitoring was there for forever. So why do we need all those monitoring and the observability? So these are one of the best thing. When we develop the system, we have to monitor where it is, how it is running flawlessly, whether the health is good or not. So for this kind of thing, we definitely need the monitoring stuffs and later the observability. I will not go with the details of those what all it is, but at least will give you the glimpse of what all it is. And I would say it is still the tip of the iceberg. You can go more deeper, you would know more. And all the fellows who are from the industry, they would be understanding more where I'm coming from and where I'm going to. So this is all about the monitoring of the infrastructure and the performance. When we are dealing with the supercomputers, where we have like more than 9,000 nodes, commodity nodes, and there are more than 30 40,000 of GPUs, and the interconnects are there, switches, ports, and all are there, where the switches are communicating with each other in 800 Gbps port, Gbps speed. So at any point of time, there's flaws, there's break, there's health is not good. So the administrator or the system analyst or the project managers or the entire system which are based on it, they hunt for, like, how to triage the issue, how to where to see, what all to look. And so this is the point where the monitoring tools comes into the picture. So if you go into the cloud like AWS, GCP, or the Azure, they have the monitoring tool, but these are all like working for like the small application which fits in the cloud and all. But the larger system, which are with like the supercomputers, which are helping the air trafficking and the aviations, the drug manufacturing, the 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 train traffics, and all those, where we cannot afford any kind of downside system, a system down, or any of the break in the system, any of the downsides of this system. At this point of time, the continuous monitoring is very much necessary. So the continuous monitoring can come into the picture when we have the sufficient data in hand. And for that, I was part of this, like, this the entire data pipeline where we were collecting the data from the supercomputers. I would tell, like, there are almost like 8 to 9,000 nodes are there. Each nodes were equipped with like 64 cores, and each of the port was constantly, every seconds, it was delivering the data. So we needed some mechanism to get the data, like if the CPU is healthy or not, if the CPU is crossing the threshold or not, if the memory is good or not, or if any of the node is not working, it is down, how to trace out that node. So that's where the place where we have, if we have the data, if we collected the data in that frequency, we would be able to tell what is breaking, where it is breaking, and how to fix them. So that's where the intention of getting that the monitoring tool or the observability tool come into the picture. So these are the things which even the cloud provider were not able to provide the seamless solution for monitoring the supercomputers. And we came into that as an in-house development team, and we developed this monitoring tool and the observability tool, which is helping the large organization in you know in monitoring the day-to-day job, and making the system seamless. So let me go to the next slide and see. We are dealing with the supercomputers which has like 10 to the power 18. It's a quadrillion floating point operations it can do. At any point of time, how do you know it is healthy? If it is healthy, it is working. And how you can make sure it will remain healthy in next 24 hours, in next week, or also. And at this point of time, you cannot afford how to cannot afford the break at any point of time. There's the uh, high stake jobs are running, and it is like it will keep on running, it will keep on running, and it will keep on delivering the results. So at any point of time, people go for the supercomputers. Is definitely the large organization, government organizations, the defense organizations, the air trafficking, and all those, where they cannot afford any kind of glitch. So if they cannot afford any kind of glitch, so we have to be on toe that the system should not break. If it is breaking, then the other, like out of this 9,000 commodity servers, if one or two or three or five servers is broken, at least that the topology, the network topology will direct them to the working nodes. So, and in order to triage those, the systems are collecting the data on every seconds in millions. So if we talk about that, the supercomputers earlier, we were having that the monolithic computers, and if you talk about the applications, we were having the single applications, monolithic applications in the industries, where we used to just see into where the problem is, we fix it, and then we are good. But when it comes to the 9,000 or 10,000 servers at the same time, it is very difficult for the admin or any of the administrator or the system managers and all to triage the issue. So this came into the picture. And the system which I'm talking about is the GPU accelerated system, and it has almost like 9,400 nodes, and it can process the data in like 10 to the power 18, floating point operations. So in usually traditional monitoring, what we do, it tells what is failing. So, and when we talk about the observability is the huge term, and there is a separate department in each industries for making this observability work when their system is very critical to them, when they want their business to be seamlessly working, flawlessly working. They have the observability team which keeps eye on their system to be running, and the systems to be running perfectly, it needs the data. And what data we are dealing with is, it's all about talking about that, how it feeds to the AI to get us the right directions. So this is like we talk about the traditional, it tells us what is failing, but it will not tell how it is failing, why it failed. So, the data though which we are collecting the data, it will tell, with the use of the AI, the machine learnings and all those, it will tell, it will go to that point where it is failing and it will tell why it failed, and it will give the development team or the maintenance team to, to take care in the next time, like how to fix those issue and make the system running perfectly fine. So in the normal world we have the threshold in the memory. Okay, when we are running the system, we put the threshold. Okay, if the CPU is being used for 90%, if the memory goes like in 70% high, then go for the auto scaling to maintain the resiliency. So you might have heard the auto scaling, scale in, scale out, scale up. Those kind of things. Those are the very common terms being used in the industry, where we, what we do, we just, in order to provide the resiliency, we just scale out, we just spin up the another machines to, to cater the needs. But here the kind of work we are doing. Okay, we are not just spinning up the machine. It is, the machines are already there. It's just the fabric connects route the jobs to the different machines if one machine is down, without telling the user, okay, that it is down. So the pattern detections and all those anomalies, all the different signals are being observed by the, AI powered. So what we do, we take the data, we make that data with the machine learning program, with that, with all the supervised and the unsupervised thing. And we train the model. We periodically, that model works in the data, and then we infer that model, and then it tells the data, it tells that what all the nodes is not behaving well, it might go down in the future. So that gives a very good idea, very better idea to the administrator, to see that what all the nodes are working and what all the switches which is going to down in next 24 hours or next hour or something, so that he can be ready with the outcomes. So you know what, I cannot go in details because the constraints are like, is the time. So for that, what all the different tools are available in the market. There are many tools are market, and every day hundred of tools are being introduced in the market. But the kind of tool which we have started with is like the Fabric Connect API pooling. This is the REST API. Is the API is the application programming interface. All the switches these are coming with, like, all the REST APIs, and they are coming with like the auto generations of their data. And we have the Kafka distributed system. You might have heard that Kafka is the distributed message platform systems, and it takes the data on continuously, it takes the data in the distributed environment, and it gives the data to the staging environment, and from there it goes to the data warehouse, like the Snowflake data warehouse. Snowflake data warehouse is SaaS system. I would say, especially for the students, who are learning that data warehousing and all those, you would be able to know that 10 different kind of data warehouse, data bricks, and Teradata, and all those once you come to the market. And so those kind of things. Now you come to the time series database. Time series database, there are different time series database, like the Victoria Matrix, time scale DB. So these are the data, which are based on the time, which will give you that the result in like milliseconds and all those, and the downsampling, the aggregate, and all those kind of things. We get the data, we accumulate the data, we downsample the data, we put the data into the data warehouse, and from the data warehouse, the actual monitoring tools get the data. It does go for the modeling.
Sorry to interrupt you in between, but we have some limited time, so can you please conclude?
Yes. So I'm just almost there. Almost, just give me just 1 or 2 minutes. I'm almost there. So these are the place where we go for the see, the Grafana is here, and you know what, Grafana is the tool from where we just show that what the system is there with the help of AI and AI ops. No, we just go and we see that where the failure are, where the anomaly detections, and what are the capacity planning is there, where how we can predict those kind of things. So that different in a ML stack we use that the PyTorch, Apache Spark, MLflow, Apache Airflow, and all those kind of things tools were being used. You would definitely get to know once you join the industry, or if you want, you can inquire about it. This is the time of AI tools and all. So you will get to know all those. So I would just once say that it is now time has gone, it is flying. Earlier we used to confine with two different language. We were happily earning our breads and butter at that time, but now we have to be on toe. We have to learn the 10 different technologies in 10 different directions. So that's all. So as I said in the beginning, especially for the students over there, you know uh, that cultivate the habit of asking, why does this system behave this way? Not only why, what it is doing. If we are doing what it is doing, if you know it is not going to take you anywhere. That shift from monitoring to observability, from alerting to understanding, is the intellectual posture of the engineer who builds these things, and that endure. So thanks a lot. Thanks for, I don't have the question answer. I can answer the questions of, if you want, in my email, if you chat and all those. So I will be very happy to answer all your questions and all.
Uh,
So that's all. Over to you, Mr. Moderator.
Thank you very much, Dr. Sohail sir, and we'd be happy to ask you another question.
Mhm.
But right now we have time constraint. Maybe some other time we'll have a separate session
Yep. Yep.
because we have lots of research scholars also. They'll be
Yeah.
interested in how AI is being used to observe, supercomputer related concepts. So we'll be very happy with that. So, but
Yep.
thank
I'll be
you.
happy to help.
So thank you very much, sir, for sparing your time. I know there's a time zone difference. It must be night there. So
Yeah, it is 1:05 at night, actually. So, I
thank,
got to go. Yep.
uh,
Okay, thanks a lot.
yeah, we really appreciate your time, Mr. Sir. Now, let me introduce our next speaker, Dr. Maria Lavina, and she is an associate professor of Department of Computational Mathematics and Cybernetics at North Caucasus Federal University, Russia. With more than 20 years of teaching experience, she received PhD in mathematics from Stavropol State University in 2005 and defended her master's thesis in information security and from North Caucasus Federal University, Russia. Her research interests include data science, machine learning, big data, cybersecurity, cryptography, trusted artificial intelligence, edtech, teacher education as well as higher level education. She has published more than 80 research papers in peer reviewed journals, Index in Scopus and Web of Science. She is an active editorial board member for Spectral Nature and IGI Global. She has served as co-chair and editor for international scientific events, including AISMA and BMAI. She has participated in international internships at Spezia University of Rome, University of Ljubljana, the Technical University of Dresden, and second ASEF Innovation Laboratory at Fudan University, Shanghai, China. Thanks, Dr. Dr. Maria, you can share your screen, please. We cannot hear your voice.
Yes, I think you can see my
Yeah,
screen and
we can hear
nice.
you. We can see your slides also. Thank you very much.
Thank you very much for invitation to present my research on your conference, and I hope you spent a good time, the students, researchers, and faculties during this conference. And I hope you find the new collaboration and maybe with me too. And again, many thanks for invitation, and let me start. Let me stop my camera and go through the presentation in the trusted intelligence, artificial intelligence sphere. Yes, as you say before, I'm Maria Lapina from North Caucasus Federal University. I have a lot of experience in ICT technologies, cybersecurity, and in international collaborations. And here is my contacts. And if anybody wants to collaborate with our team, you can be free and write to me, and we will be in touch in different years in scientific research, or maybe join events, and we'll see in the future what will be. And let me tell you about my university. We have more than 25,000 of students and more than 2,000 of teachers, and we have a lot of researcher groups. And here is the map where you can see our university between the Black and Caspian Sea, and between us you can see not very long distance. And here is my research topics, and you can see that I have a lot of different points in computer science. And today we will talk about cybersecurity and trusted AI. I have some scientific achievements, and I'm a member of the scientific team of the grant that also connected with cybersecurity and trusted artificial intelligence. I spent very good visit. I have a very good visit in your university, and thanks a lot for this warm visit, and I hope for future collaboration too. Let's see on the development of artificial intelligence technologies from the previous age. And as we feel now, this technology developed speed, and some time ago we talked about GPT-4, and we talked about AI agents, and then we use the large language models, and now we can see the large multimodal models that we use in our research, and the companies can use them in their business process too. And that's why it's very important, the question about can we, how we can organize the AI systems, and how we can trust this system, because this system use our data, not only personal data, the data of the companies, and we need to be trust that our data will be safe. If we will see about on AI technologies and robotics, and we have the question, when will AI and robotics replace us? And you can see the picture where you can see the brain technologies that will be, I think, with humans, with the people. And for AI technologies, we share the we give the routine tasks, and in other topics that will be very difficult maybe for us, and this technology will help us save our time to do the good work, and it will be the new age in technology, I think. If we see on the strategies of AI integration, we have the different ways. it's a symbiosis, the first, and maybe mutation in second, and it's a bad way of replacement of this technology, the humans. If we ask AI technology what it can do better than humans, you can see the answers. These answers prepared with AI, of course. And we can see the qualities that will be better for humans, and the qualities that can do better with AI in this year. I think in the future the situation of course change, but now you can see that data and scenario analysis will do with AI better, and information processing speed too. And the humans will do the intellects work, and the work that associate with the brain and maybe cognitive abilities. If we think about the today's large language models, let's go through the this technology from the previous years. And in previous age, we talk about artificial intelligence in the middle of the previous age, and then we go through the machine learning and deep learning. Some years ago, we start to use the transformer architectures, and now we use a lot large language models. Of course, AI have some risks, and here you can see the main risks of using AI. And today we will talk about how to protect our data of these risks too. And if we talk about ethics and the law documents, you can see here the main documents from the cybernetics. It's like a previous age, and of artificial intelligence ethics law documents here on the slide. If we see of the national initiatives, so you can see a lot of documents in every country that connected with the AI technologies, ethics, and in other principles. And if you see on the corporate standards, also a lot of big companies think about how to organize the trusted AI and use and save the data so that will be used in AI technologies. Also, these initiatives not only in every countries, also big unions also use and think about how to use the ethics of artificial intelligence. In our country, of course, we have the National Code of Ethics, and here you can see the general characteristics of this code and implementation mechanisms. And I think in your country, you have the same documents as we saw on the previous slides. And we have the 7 principles of this ethics. And you can see them on slide 2. And now we have very difficult complexity structure of the types of cyber threats. You can see here on the right the classical system based on the clear classification, but AI and machine learning models based not on the same types. That's why we have a lot of questions, a lot of problems, how to organize our data well to save them. If we see on the life cycle requirements of for AI and machine learning systems, you can see the 4 steps it's analyze and design, development, testing, and maintenance. And you can see the points that include in every of these life cycle requirements. And after this short travel in AI technologies, let's talk about how we can trust AI. And we have two different definitions. It's trusted AI and safe AI. And here is on the picture, you can see that safe AI include in trusted AI. And we can organize the trusted system that must be safe. And here is in this round, you can see the different points of trusted artificial intelligence, like robotics, privacy, ethics, security, safe AI, and others. And let's talk how we can use the principles of trusted AI. You can see this list of principles, and I think you know about them. It's not very difficult, and these principles are connected with the principles of organizing the every system. And let's try use these principles for organizing the trusted artificial intelligence systems. If we will talk about why the AI system can be attacked, so you can see on this slide the types of attacks on machine learning systems. And it's a different types by the object of these attacks. So the first time it's attacks during the training phase. The next time it's attacks during the data retrieval phase. So the next it's a privacy attacks in and exploit attacks. You can see here the some tasks, some points that include in every of these type of attacks and some examples. But let's see some examples and the methods of treats of these attacks, methods of protection of these attacks. So here is the main structure, how we can use the types of protection of attacks on machine learning systems. And you can see the 5 points, how to organize this. And every of this direction have a lot of methods, but we have very short time, so let's see on some of them. We know that LI systems is very difficult, and it's the main problem. It's a poor interpretable. And we know about dual nature of machine learning systems. So we have also the agent nature of this system. And we know if we change the correct data, so we have the destroyed model. And we talked about the poor interpretable of these models, and about dynamic structure of machine learning models. And also we know about hallucinations of results of the models, and then we get the results that are not the right then the model work and give our the output data. And here is you can see the levels of harm influence. I know about my 2 minutes. Yes. And we can see some examples. I think it's a interesting part of the presentation. Here is the adversarial examples. Then we use the noise and the picture of panda detected with machine learning systems as a gibbon. And another example of adversarial glasses, then some people can use this type of glasses, and these guys can't be detected as themselves and detected as another person. And here is the example of data Python, and you can see here how organized the attacks. And it's a next one example of the attacks, how the chatbot works, and the people ask them not very good questions, and the model training on the bad questions and start answer not like it was organized by the company that developed this bot. And also the backdoors attack. Look on this picture, we have the stop signal, and if we add the small square on this symbol, so the brain detected this not like a stop and detected it like another signal. I know that we can talk a lot about this year, about the type of attacks on machine learning systems, and talk about examples, how it's organized, and I have some mechanism how we can treat, how we can protection our machine learning systems through attacks. But I think it will be maybe my next presentation, and we will talk about this next time. Thanks again for your time, and for inviting me like a speaker on your conference, and I hope for new collaboration.
Thank you, Ms. Maria, for joining us, and it was really nice topic and timely topic of trustworthy artificial intelligence and responsible and safe AI systems. Those who do not know, Dr. Maria has visited our department, I think last year. She is an active research collaboration with Dr. Mohammed Sajid. And Maria will be happy to host you once again whenever next time you visit our campus. So thank you once again for your time. So let me now introduce our next speaker, Dr. Shahid Tofel. Dr. Shahid is a senior data scientist at Next NRG LLC, Florida, USA, specializing in artificial intelligence, machine learning, and smart energy systems. He holds a PhD in electrical and computer engineering from Florida International University, USA, where his research focused on smart grid security, fault diagnostics, and false data injection detection using advanced ML techniques. With a strong interdisciplinary background spanning electrical engineering and computer science, Dr. Kufel has expertise in renewable energy forecasting, cyber physical system security, anomaly detection, and predictive analytics. His work integrates AI-driven solutions with real-world energy infrastructure to enable intelligent monitoring, optimization, and enhance reliability of modern power systems. He has authored over 20 peer-reviewed publications in leading AI journals, IEEE conferences, and has presented research at major international forums. An active IEEE member, he also contributes to research community as a reviewer and mentor to advance the integration of AI in sustainable energy systems. Thank you, Dr. Shahid, for joining us today from USA, and I would like to invite you to share your expertise with us. Dr. Shahid, you are not audible. Your slides are visible. Dr. Shahid, can you hear us? हाँ, शुरू सर। डॉक्टर शाहिद सर थोड़ी देर में ज्वाइन किया था। Dr. Shahid, can you hear us? Yeah, please unmute yourself, Dr. Shahid. You are on mute, Dr. Shahid.
प्लीज अनम्यूट आप म्यूट दिख रहे हैं आप म्यूट दिख रहे हैं बस म्यूट करेंगे
Can you try once again to rejoin? I mean, exit the meet and try once again.
एक बार रीजॉइन करेंगे आप एक बार रीजॉइन ठीक है उसको लॉग आउट करके एक बार रीजॉइन तो भी हैंग होगा हो गया ना find that
Can you hear us, Dr. Shahid?
I can
Yeah. You are audible now.
will you share your
Yeah, please share your screen and you can start your talk, Dr. Shahid.
So can you see my slides?
Yeah. We can see you. We can hear you as well. And your slides are also.
So good morning, everyone. Thank you for inviting me here. I'm thankful to all the committee members and Dr. Arman and everybody here. So my name is Dr. Shahid Tufail. I am a senior AI/ML developer at Next Energy in Miami. I did my BTech and MTech from Aligarh Muslim University and my PhD from Florida International University. So for the today's topic of discussion is machine learning evolution in power system research. So coming to the contents, these are the contents which we'll be covering in this presentation, which includes introduction, motivation, historical evolution, why machine learning always wins, core machine learning applications, what's the future of machine learning in power systems, what are the key challenges, and what are the open areas of research, and generative AI for the researchers in power systems, and then key takeaways followed with the question and answers. So coming to the So coming to the why machine learning always matters. So as we see right now, the current grid which we have is underutilized. It's only utilized 50% of its capacity, and that is because these grids were designed for the peak load demand. However, when we see the peak load demand is not stable, it fluctuates. So machine learning helps to reduce that conservative approach by improving the visibility, forecasting, and the controls. So in that way, it it assists the existing assets that can be used more efficiently without any adding any new infrastructure for energy production. Next, we see the according to IEA report, by 2030, renewable penetration will be about 30% into the grid. But this is a challenge because the wind and the solar penetration increases the variability, uncertainty, and it also increases the dynamics on the grid. So thus it is very much critical for better forecasting, flexibility management, faster operation and decision making. Machine learning becomes an important task here because it helps the grid to respond to the like changing the renewable condition more intelligently. And due to all these problems which current industry is facing, we see that AI in the energy market is expected to be $59 billion by 2030, and which is a huge number. This shows that the utilities, current grid operators, and technology firms, market participants are heavily investing into the AI-driven software for forecasting, optimization, asset management, and the system security. And so this field is like growing not only in academia but also in the industry at very high pace. And we need machine learning because it is much more faster than traditional physics based approach. Like many traditional physics-based approach heavily relied on simulations, like thousands of equations running in the background, computing, and then presenting a solution. But machine learning is very fast when we compare to that. And moreover, machine learning can also handle all the non-collinear relationship between the data. So machine learning is for everyone. Like what I say with machine learning is for power engineer, for computer scientists, and everyone who is interested in this in any kind of research, including environmental researchers and the material scientists. For power engineers, machine learning matters because the grid now demands faster and more adaptive analytics. It supports the real-time simulation, predictive maintenance, and autonomous protection strategies. For example, in the previous presentation, they were talking about the how the system will fail, when the system will fail. This is all data-oriented research. When we analyze the historical data at the real time to find like what is the status of the system, what the status of the asset, and how it is going to fail. What's the probability it will fail in near future? What is the lifespan of this remaining useful life? For computer scientists, since we are seeing the huge velocity, volume, and veracity of the data, computer scientists comes up with intelligent machine learning based solutions to handle those high paced data with novel machine learning methods. And for anybody in the industries looking for those kind of solutions. Coming to the historical evolution, on this slide, we present the historical machine learning, how it evolved right from 1960s to the present. Earlier, these were dominated by the perceptron, linear regression, and expert system. Basic rule-based approaches that saw limited application in forecasting and fault diagnostics. However, when we reached 1990s, it was the era of artificial neural network and support vector machine, and which were used for short-term load forecasting and power quality classification. And by 2000, when we saw the evolution of technology for storing more data, we got more computational power. We saw models like resource intensive models like random forest, gradient boosting applied to predictive tasks. And as we moved to 2010s, we saw a huge boom in the deep neural network model, for example, CNN, LSTM, These were used for predicting the long term and the short term forecasting in different domains of the power system. We are seeing that that uh, that huge increase in the graph neural network model, the transformer architecture, and the generative AI, which are resource intensive, but thanks to evolving technology of the storage, faster read and write operations on different architectures. So this has been evolving fast 60 years. So and this slide shows like how the academy is reacting to the machine learning and the power system, and we see that there is exponential growth in the research which is coming for the power systems and the machine learning. And we saw that the first, like the first paper was in 1991 on the ANN for load forecasting, and the surge in publication reflects the growing industry interest driven by the reducing computational costs. So what machine learning has changed? Like on this, like we see here what was before machine learning and the after machine learning, what has changed. And so we see that in load forecasting, before machine learning became dominant, forecasting was heavily relied on the statistical models, for example, ARIMA models, and these approaches were useful, but it's still like they were very slow to converge and very limited, very limited applications. While today, since we have more and more resources, we can train large models, like for example LSTM, transformer based hybrid models, which captures the non-collinear relationship temporal structures much better than these statistical model were doing. In the next, we see the era of fault detection. The traditional models depends on the relays, thresholds, and rule-based models, whereas machine learning sees the data, sees the output, and then builds its own rules. So machine learning is fast, and it can often detect faults in milliseconds, which improves like the protection speed and the situational awareness. Another area which is very getting highly famous in the academia is the renewable integration. As we know, like renewable energy resources are intermittent in nature. So we need accurate forecasting of those. So machine learning based forecasting, operators can estimate the renewable output power generation more accurately, which reduces the uncertainty. Because as we see, uh, r- earlier in before, we had the generation and we have the consumption. We didn't have any kind of renewable resources which were intermittent. So the generation and consumption, they were linear, like how much has to be consumed will be produced. But with the implementation, with the integration of the renewable energy resource, it became more challenging because these were intermittent in nature. Another area is the maintenance. Maintenance is the one of the key area where machine learning plays a vital role. It helps in identifying the where exactly the fault is, what time the fault occurred, and making a whole picture, like when the fault can reoccur, or what are the components that may fail in future, and what are the remaining useful life of those components. If we are able to estimate those very accurately, then we can reduce the downtime significantly. Another is grid planning and the feature engineering. So earlier, there were very limited features for any model, but now, since we have a huge volume and the velocity of the data, so due to that volume and the velocity of the data, we have very high dimensional data, which needs to be like a huge feature engineering is required to handle those kind of high dimensional data.
Sorry to interrupt you, Dr. Welfare. Can you please conclude? We have very limited amount of time. Sorry for the shorter time.
Mhm.
Can
Sorry,
you conclude, Dr. Tufel, or we have actually?
yes, sure.
Oh, thank you very much.
So, these are the traditional approaches which why machine learning is important to us, like in the current scenarios. And so these are some core deep learning models which we apply in our research, which we use for different types of tasks. For example, for solar forecasting, transformer models to predict to predict how much the generation will be there, and the CNN models to identify the faults in the PV system from thermal images. So as we have discussed, these are some core applications where currently the academia is moving to for applying machine learning, which include like price and load forecasting, solar and wind forecasting, fault detection and classification, energy storage optimization. So energy storage optimization is important because energy cost, the storage cost is very high. So we have to optimize its dispatch. We have to optimize its life expectancy based on how much it is going to dispatch. This pipeline is the core machine learning pipeline, which Dr. Lapina also discussed. That we first get the data, we first pre-process, then we apply the machine learning, then evaluate the results, then we move to deployment. So the most important stage in this pipeline is the pre-processing, pre-processing, which takes most of the time. So what's the future? Future is like physics informed neural networks, since they are very highly optimal, and they can fasten the inferences. And the foundation models for the grid, for example, pre-trained machine learning models, federated learning to enhance the privacy preservation and grid autonomous grid operations. And this is something like generative AI for the researchers, and how we can use generative AI for our machine learning, for example, for writing codes, for synthesizing the literature, for synthetic data generation, because the core machine learning data is sparse and skewed. So we need to have more and more data to train more machine learning model and make it more generalized. So these are some key challenges which we face during the machine learning process, which includes the data scarcity. As we know, like data is very scarce. For example, if you have cyber attack, so you have very few instances of those cyber attack instances. So data scarcity is one of the problem. Interpretability and the trust is another problem. For that, we apply explainable machine learning methods to combat that. Reproducibility and generalized distribution and shift, real-time safety constraints, and regulatory and cybersecurity as. So these are some key areas which are open to research, which has been very much discussed in most of the literature and the current opportunities for the proposals and all. So we have the same thing: the explainable AI, synthetic data generation, transfer learning, multi-agent reinforcement learning, and edge machine learning. So yes, so I'm open to questions. Thank you so much.
Thank you, Dr. Sofel. We in some other situation we'll be happy to take questions from students, but due to time constraint, we won't be able to do that. But your topic is a good food for thought for our students to know that AI technologies are not being used only in domains related to computer science, but they have made their ways to power systems as well. So it was a good starting point for us. Thank you, Dr. Sofel.
Thank you, sir. Thank you very much.
We really appreciate your time as well. Let me now introduce Mr. Mehroz Ali Pasha, who is thankfully present with us today physically. And Mr. Mehroz is the founder of AHA Technocrats, a Noida-based software development and digital solutions company, and brings with him over 14 years of extensive industry experience. Under his dynamic leadership, the company has successfully delivered a wide range of scalable web applications, SaaS platforms, and enterprise-grade solutions across multiple domains, including our own website of the university, that is the official website for Aligarh Muslim University. He completed his graduation from Aligarh Muslim University, so he's a proud alumnus of our university, earned his MBA from HBTU Kanpur, and further enhanced his expertise by pursuing a specialized course in supply chain management from IIT Kanpur. With a strong vision for innovation and practical learning, he is actively committed to bridge the gap between academic knowledge and industry requirements. His work particularly emphasizes emerging areas such as AI-driven development, modern software engineering practices, and real-world applications of technological solutions. So we are fortunate once again to have Mr. Mehruz with us today. Now I would like to welcome him on the stage to share his expertise with us.
Thank you, Dr. Nadeem. Respected presiding chair, Dr. Pradeep Saab, respected chair, and the respected Professor Arman Rasool Saab, Chairman, Chairperson, Department of Computer Science, Aligarh Muslim University. So, Assalamu alaikum, good morning.
Good morning.
Everybody.
Good morning.
Not long ago, I was sitting here in the room, and I was also looking at this stage and trying to find out the solutions to bridge the gap between the knowledge we acquired in this prestigious institution and the expectations of industry. With the emergence of computational intelligence, the gap isn't just widening, it is evolving. Looking back at my journey as a founder of Art Technocrat, I realized the challenge was not the lack of knowledge, it was a lack of real-world execution. Companies are no longer hiring only for your academic excellence or your pedigree. They are also seeking for the proof what you have built. So my speech is not going to be a motivational speech or a very in-depth technical speech, because we already have a very rewarding session from previous speakers on AI, ML, and its importance. What I'm going to talk about is practical reality check from the front lines of the industry. But my personal experience is just not an outliner, it is a reflection of national trend. If we see that the India Skill Report 2025 recently revealed a staggering statistics that only 54.81% of our graduates are employable. Just imagine the number. Almost half of our talent coming out of our universities and colleges in India is not ready to be absorbed by the market. They need training before getting into the industry. So, and another important aspect of this report is the highest demand from employer is not just the technical syntax, but it is for communication and soft skills. Industry is still starving for people, those just can't write code, but who can articulate a solution, collaborate in a team, and understand clients' why. Because if you are a software developer, I'm talking about software development because we are coming from that background. So if you are a software developer, you must know what you are coding, and you're coding for whom. So if you are a software developer, you must be able to explain to a client a solution you are developing who is sitting in US or Canada or somewhere else. So let's also address the elephant in the room, the AI. So what impact AI has brought to the software development industry? We are moving from the manual coding to intelligent design. If we talk about the effect this has, brought to the software development, Sundar Pichai recently said that most of the new code written at Google, means 25% of code written in Google is being generated by AI. And Microsoft goes further. They said 55% of the event efficiency of 55% has improved for their developers by using Copilot, GitHub Copilot, and other tools. So the shift is impacting the workforce globally. The IT industry, which has seen a steep growth or stable growth of 15 to 20% in the last 20 years, it is struggling. Even giants of industry are struggling. And we recently have seen the news what Oracle has done. They have almost laid off 12,000 resources out of 30,000 in India. So it doesn't mean software development is dying. It means mediocrity is being automated. The low skills is going to be automated sooner or later. It's not only the software development, but data science, data engineering, and in other fields as well. And I'll give you a real world example from our team at High-Tech Technofeds. We recently developed a new platform for a US-based client. It was called the selfish.com. It's a social networking platform where golfers can book golf trainers, they can chat, it's more of like LinkedIn, but it's for golfers. Imagine how long the team has taken to develop that solution. It's only 45 days. And imagine the team size. It was only 3 people plus a QA. Otherwise, before 2 years, I would say it would have taken 10 people to develop that solution, and it must have taken 6 months or so. And the solution might not have been that solid because it has been launched. It's not a soft launch. It is hard launch. Actual users are coming on the platform. So that is the magnanimity of AI on software development industry. So, and one more interesting aspect of the team, guess the education background of the team members. One of the team member was 12 pass, and he was having experience of 3 years. And he was able to deliver a product for US market who outperform the veterans. So this is what it is happening in the industry. Industry is evaluating you not only on your degree or your mark sheet, they are evaluating you on the ability to build. The skill is becoming more visible than qualification. Tools like Ripple, a no-code platform, a single builder can now do what used to require a full department. And to add this, I would like to quote Dario, the CEO of Anthropic. He recently said software engineering could become obsolete in 6 to 12 months. He does not say a year or 2. He just says few months, and that shift is happening. We at our office, we can feel it across the industry, and the kind of pressure IT software industry has. So it means the value of engineering is shifting. Writing code has become a commodity, and designing a solution is a new premier. It rewards clarity, experience, and judgment. The role is not disappearing, it's leveling. So in 2026, skill is louder than qualification. Your resume is a PDF of promises. Your GitHub is a history of proofs. Your companies are not hiring for degrees, they are hiring for what you can deliver. Your resume does not matter, your GitHub profile does. My advice to the students here today is simple. Stop passive learning, start building. Stop being a tutorial tourist. Watching a 10-hour video is a passive learning. Real learning happens in a brutal and necessary cycle, and that is build, fail, fix, and repeat. Build, fail, fix, and repeat. So that cycle will give you what industry is seeking. Your GitHub resume is real. Your portfolio is your real degree. I challenge you with one small, project. Find out a solution in university or in any small scale business. Try to solve that solution that problem. Build that using Rebuild or any AI tool. Start committing on GitHub and publish that online the results. I leave you with this. Your first salary is decided 2 years before your graduation. Your comfort zone is your biggest career risk. You cannot take because things are not changing in years. They are changing in days. You have two choices now. Compete with thousands of average developers for dwindling number of basic roles, or become one of the few who actually build things using the tools of future. Future won't ask you for your marks. It will ask, show me what you have built. The future does not belong to those who know the most, belong to those who can execute the fastest. Start today. Thank you for having me.
Thank you, Mr. Meadows, for a very insightful talk. And this is the benefit for being available physically, I must say, because everyone was able to connect this time. And very insightful points from Mr. Meadows. And I highly recommend all the students and scholars to at least pick some of them because all of them are useful. One last experience from my side, that is, we saw the research papers and majority of them came from AI. I think 50–60%, and it is interesting to see even that all the talks were all about AI in some sense. So our conference, computational intelligence, makes sense at least in this time of era. So huge round of applause. So we are already short on time. I will not talk much and directly call upon or invite our presidential chair, Dr. Parvez Mahmood Khan, sir, to deliver his address.
Welcome all the dignitaries on the dais and off the dais and all the young talent of India, future of the country. All the four talks were very, very relevant. They were relevant to the theme of the conference, emerging computational intelligence. Now, some focused more on the technical side, others in terms of the employability, which is employability is actually ability to not to find the first job, but that is called placement. So employability is ability to retain the job, ability to progress in the job, ability to get progression in the job. That is what. So we should focus more on the employability rather than on the placement. Placement one may get and one may quit because of not being able to perform. So employability enhancement is very, very relevant. And as far as the computational intelligence, the theme is concerned, all four talks are very relevant. They were focusing either on supercomputing or on AI or on ML aspects in some domain. Now, in computational intelligence, actually, we are here, we should be problem solvers. So as a problem solver, the industry is looking for problem solvers. There are a lot of problems, real-world problems that needs to be solved. In order to solve the problems, people have been talking about AI is going to take the job, AI is going to take it. AI is not going to take the job. Jobs will be taken over by those who know AI. So it is high time we learned AI-powered tools and take over the jobs. AI is never going to take the job. Only those who know AI will take over. Now, the areas, there are some complex problems. There are problems for which mathematical model exists. There are problems where traditional modeling is feasible. But there are problems for which neither traditional model is feasible for one reason or the another, nor mathematical model is feasible. It is for those domains that is where we look forward to computational intelligence. Why? Because it is too complex for mathematical modeling, or the process itself is uncertain, ill-documented. So there is an element of learning, adapting, and then taking decision, making decision or decision support system. That is where. So all four talks are very, very relevant. And the word of advice for our young talent of the nation, all the students, that these talks would have triggered some ideas. Please pursue those ideas and take forward the research in the direction of computational intelligence, so that by the time we meet next after a couple of years, third conference, you would have already progressed a lot and you would have written next level of papers. With that, I'd like to conclude because we are already running late on time, so will not take too much of time. So the word of advice: take over the job by learning AI. Don't get stressed that AI is going to do the job, but you should learn AI, will be more productive, and then take over the jobs. Thank you.
Thank you, sir, for your insightful and inspiring address. Your guidance and encouragement are deeply valued by all of us. As we approach to the conclusion of this session, it is my time to express our gratitude to all those who made today's program successful. It is my pleasure to invite Dr. Faraz Masood to propose the vote of thanks.
I will be very address. Respected dignitary, distinguished speakers, esteemed participants, and dear colleagues. It is my privilege to propose the vote of thanks for this insightful session on industry and invited talk. We extend our heartfelt gratitude to our distinguished speakers, Mr. Mohammad Suhail, Dr. Maria Lapina, Dr. Shahid Tufel, and Mr. Mehruz Ali Pasha for sharing their valuable insights and real world experiences, joining us from different time zones and traveling long distances. We sincerely thank Mr. Mohammad Suhail for his talk on infrastructure and performance monitoring of fabric interconnects in supercomputing. He also shared his personal information, so we can connect with him. He shared tools like Kafka, and the main code that he has given that we should learn about why this system behaves like this way. Then we have a talk from Dr. Maria Lapina, who shared why trusted artificial intelligence is important. Then we have talk from Dr. Shahid Tufel. We thank him as well for his talk on machine learning evolution in power research systems. And he mentioned how the publication has grown in this field. So for scholars, for new students, we can take from that we can go in this area, and we will have our research with on AI with power systems. And finally, we have a talk from Mehruz Ali Pasha, and he discussed the main thing that we should work on build, fail, fix, and repeat. So we all should take from that we should build, fail, fix, and repeat. This session has beautifully demonstrated the importance of bridging the gap between academia and industry. Such interactions not only enrich our academic understanding, but also prepare us to address real-world challenges with practical and impactful solutions. What I get is that I always feel that there is a difference, there is a gap between academia and industry. But during these talks, I realized that with AI, this gap is automatically bridging. Our students are working in these fields which are very close with the industry now. We can easily, as Sir said, that a 12th pass student who has experience of 3 years, he is developing complex systems. So our students can do that as well. Earlier, it was not possible. So I would like to express sincere thanks to the organizing committee, session coordinators, volunteers, and technical team for their seamless efforts in making this session a success. Finally, we thank all participants for their active engagement and enthusiasm. Thank you for all once again. Thank you.
Thank you, sir, for concluding the session and conveying our gratitude so beautifully and sincerely. Ladies and gentlemen, With this, we come to the conclusion of this session. On behalf of the organizing committee, I extend a sincere gratitude to all our respected speakers for sharing their valuable knowledge and insights with us. Your contributions have made this session truly meaningful and enriching. We also thank all the participants, faculty members, researchers, delegates, guests, and volunteers, and all the alumni and students watching us live on YouTube for your active presence and enthusiastic participation throughout the program. Thank you so much to each one of you for being part of this academic gathering. Before we proceed to the next segment of the program, I warmly invite everyone to join us for refreshments. Thank you once again, and we look forward to seeing you all back shortly for the next session. Following the refreshment break, we will reconvene for the plenary session 2 at 11:45 a.m., which will be held right here in the conference hall of the Department of Computer Science. This session will feature insightful discussion on cybersecurity, AI automation, intelligence, and human trust. We look forward to your presence and for what promises to be a highly engaging and informative session. Thank you so much, and please do enjoy the refreshments. That plenary session 2 will start at 12 because we are a little late. So please reconvene here at 12.